Here we have completed the bending moment diagram. This is the BMD. Now as we see in the bending moment diagram, there are 2 points where bending moment is changing its sign, or you can say bending moment is 0 at these 2 points, and these points they are called as point of contraflexure. So here I have 2 points as the point of contraflexure, as we can see. So we need to know the location of these points. I will start with the first point. I'll say that this point, the first where the bending moment is changing its sign, I'll say that this distance is x1. So now I will find how much is this distance x1, and then I will be calculating x2. So first for x1, I'll say that the step is step number 4, location of point of contraflexure, and for that I will draw 2 similar triangles. First, the triangle having base x1 and the other one which has base, since 4 meter is the total length and from A I am taking distance as x1, so the remaining distance is 4 minus x1. So I will draw these 2 similar triangles. So here I have 2 similar triangles. From this I will say that if I take the height of first triangle, that is bigger triangle, upon the base of the bigger triangle is equal to height of smaller triangle upon base of smaller triangle. So therefore I have 20 into 4 minus x1 is equal to 6.87 x1, and here if I multiply that becomes 80 minus 20 x1 is equal to 6.87 x1, and therefore x1 value, if I calculate, I will be getting this as 2.8 meters. This 2.8 meter is from point A. So this is from point A. So I have located the first point of contraflexure. Next, I will locate the second point of contraflexure, and that is I locate it with respect to point B. I'll call this distance as x2, where the bending moment becomes 0, and again I'll say that by similarity of triangle, here I have a triangle whose base is x2, height is 45, and I have a smaller triangle whose base is, since this distance is 3, if I am taking x2 from B, this is point B, from this if I am taking x2, so the remaining distance is 3 minus x2, and the height here is 6.87 kilonewton meter. Now I'll say that again by similarity of triangles, if I take height of smaller triangle upon base of smaller triangle is equal to height of bigger triangle upon base of bigger triangle. So therefore here I have 6.87 x2 is equal to 45 into 3, 135 minus 45 x2. I will be bringing x2 term on one side, number on one side, and calculating this part. From this I will get my x2 value as it is 0.4 meters from point B. So as we can see in this problem, we had solved all 3 questions which they were asking. The first one, reaction at A, reaction at B, we have already calculated. SFD and BMD, we have completed the shear force diagram, bending moment diagram, and the last part was point of contraflexure. So here we have located the point of contraflexure x1, the distance is 2.8 meters, and x2, the distance is 0.4 meters. And once we have located the point of contraflexure, we can say that the problem is completed.